when we think about atoms, there's a couple different ways to think about them. The classical way is to think of it with what's called the planetary model, where the nucleus is kind of like the sun, and what orbits it would be the planets. But more recent research beyond that shows that it's more like an orbital model, where the electrons are surrounding the nucleus in kind of a cloud. But you can think of it in either way. Atoms are going to have three subatomic particles, and you should know those particles and be able to identify how many there are by looking at a periodic table. So a periodic table will be available for you on the exam. Protons are positively charged, and they weigh 1 atomic mass unit. The neutrons are also in the nucleus, and they have no electrical charge, but they also have 1 atomic mass unit, which is what AMU stands for. So notice the nucleus here, we have red and yellow. That signifies protons and neutrons. So let me label them for you. The red would be the proton, and the yellow would be the neutron. You could see I'm using a superscript of plus or zero, signifying the charge of it. Then the electrons are going to have a negative charge, but they are very insignificant as far as size. So essentially, it would take 1/1800 electrons to equal the weight of 1 proton or 1 neutron. So they don't have any importance as far as weight, but they're important for the charge and also what's called chemical bonding, which we'll be talking about in the future. So when you identify atoms, you can identify them just on the base of the number of protons, because that's the number that's on the periodic table. It is the smaller one, and there's a great periodic table. It's in the appendix of your book. You can easily get to that on the ebook much more easily. So that's why I prefer the ebook. But different elements are going to contain different numbers of subatomic particles. So when you look on the periodic table in the upper left-hand corner, you see hydrogen. It has 1 proton, so it'd have a number 1 in it. Helium is in the upper right of the periodic table. That's a 2 because it has 2 protons. And then lithium would be directly underneath hydrogen. It has the number 3 for 3 protons. Now, everything that's on the periodic table, if it's on the periodic table, it's going to be neutral. So that tells you right away that it has the same amount of electrons as protons. So hydrogen would have 1 proton and 1 electron, making it neutral. It has 2 protons and 2 electrons, which makes it neutral. Lithium has 3 protons and 3 electrons, which makes it neutral. Now, the neutrons, remember, do not have a charge. So it just so happens hydrogen does not have a neutron, which is why it's referred to as just a proton and has a very acidic effect. Helium happens to have 2 neutrons, and lithium has 4 neutrons. The reason that's significant is because remember, the protons and the neutrons are the only thing that basically weigh anything. So when you calculate the mass of an atom, you only need to concern yourself with the mass of the nucleus, which, as you know now, is containing the protons and the neutrons. So some very important terms that you need to know would be the atomic number, first of all, and the atomic number corresponds to the number of protons. The mass number is the mass of the um, entire element, and it's going to be a rounded number, and it's the nucleus, the protons plus the neutrons. Because remember, the electrons don't weigh anything. An isotope has a different amount of neutrons, and it's kind of a variation of an element. And we'll be seeing an isotope coming up. The last thing is the atomic weight, which is the decimal form. So it's similar to the atomic mass, and it's going to be the number of protons plus neutrons, but it's the average of all known isotopes. So we'll see that again on this next slide here. And we're going to be looking at those first three elements: hydrogen, helium, and lithium. So hydrogen, as you can see, has one proton and one electron because it's on the periodic table. Helium has two protons, two electrons, again because it's neutral. Lithium has three protons and three electrons because it's neutral. The number of neutrons, again, is not going to correspond to protons or electrons. It just so happens hydrogen doesn't have any, helium has two, and lithium has four. So again, these are very important terms for you to know, and you'll be asked these on the exam. So the atomic number is the number of protons, and it's going to be the smallest number on the periodic table. So when you look on the periodic table, you'll see two different numbers. The mass number is a whole number, and it's the protons plus the neutrons, which remember is basically the mass or the weight of the nucleus. An isotope has a different amount of neutrons, and the atomic weight is the average of all isotopes. So it's the large number on the periodic table. So I'd like you to take a look at your periodic table real quick in the appendix, and we're going to look at carbon as one quick example. So carbon, obviously the symbol is C. It's going to have a number of 6, which is the atomic number, the number of protons. Then it's going to have a number 12.011, which is the atomic weight. It's the average of all known isotopes. It's not the same as the mass number. The mass number is just the rounded number, so it would round down to 12. So this slide is going to show the isotopes of hydrogen. And in the case of hydrogen, there's no neutrons, but these are two isotopes of hydrogen: deuterium, because there's one neutron, and tritium, which has two nitrogens. And the one example of how we use these in medicine is so that we can identify problems that a patient might have. So they're radioisotopes, are isotopes that decompose to more stable forms, and they're valuable tools for biological research in medicine. Some can destroy localized cancers, but they're also very important for diagnosis of diseases. So these are examples of imaging that you can see here. So where the red is, for example, is because of an isotope. Green in this case, this is from what's called a barium swallow. And I wanted to write in the quadrants that you learned about in chapter 1. A barium swallow means that a person is going to drink a solution that contains a barium isotope, and it is going to show this image that lights up that the radiologist would see.